Hello everyone, so we meet again. So today we continue with 1.1G, part 3 of chapter 1. Our learning standard for today: sketch graph of quadratic function. When sketching the graph of a quadratic function, the following characteristics should be shown on the graph. Okay, the first one, the correct shape of the graph. The second one, y-intercept. And the third one is the x-intercept, or one point that passes through the graph. These are the three characteristics should be shown on the graph. Okay, now I want you to refer to example 8 and example 9 in your textbook. Okay, example 8, we show you case 1 where the graph of a quadratic function intersects the x-axis. Meanwhile, example 9, we show you case 2 where the graph of a quadratic function does not intersect the x-axis. Okay, remember the first one intersects the x-axis and the second one does not intersect the x-axis. Okay, let's sketch the graph for example 8a. Given the quadratic function fx equals x squared minus 4x plus 3. Okay, first we determine the shape of the graph, okay, by referring to the function a equals 1, which is greater than 0. So this is the shape of your parabola. Okay, a parabola with minimum point. Okay, smile shape. All right, then you determine the y-intercept. Okay, for fx equals x squared minus 4x plus 3, the value of c here is 3. Okay, remember the constant c of a quadratic function is the y-intercept of the graph of the quadratic function. In a very simple word, c is y-intercept. Okay, c is y-intercept. So c equal 3, so that means y-intercept is 3. Okay, next we determine the x-intercept. Okay, at x-intercept, the value of fx equals 0. So when fx equals 0, you will get equation x squared minus 4x plus 3 equal 0. Then you factorize this quadratic equation. Okay, remember we have learned to factorize quadratic equation by factorization in the last subtopic. Okay, so here the factors for x squared minus 4x plus 3 are x minus 3, x minus 1. Therefore, the x-intercept is 3 and 1. The next step, we sketch the graph. We draw the horizontal axis and vertical axis. Always remember, always draw a straight line using a ruler. Okay, using a ruler. Okay, here we draw the horizontal axis first and then the vertical axis. Okay, next, don't forget to label your graph. Okay, for horizontal axis, label with X. Then for vertical axis, we label with Fx. Okay, the origin is 0. Okay, then mark the y-intercept. Okay, the y-intercept is 3, so 3 is around here. Let's say 3 is around here. Okay, then x-intercept, so 1 is around here and 3 is around here. Then you can draw your parabola on this axis. Make sure your parabola pass through all these 3 points. Here we go. This is the graph for fx equal x squared minus 4x plus 3. Okay, now let's try to sketch the graph for example 8b. Okay, for 8b, given the function fx equal x squared minus 6x plus 9. Okay, the first step, we determine the shape of the graph. You know that a equal 1, which is greater than 0. So you get a parabola with a minimum point, okay, smile shape. And then the second one, you know that c equal 9, so that means the y-intercept is 9. Okay, and then the third step, we determine the x-intercept. Okay, at x-intercept, the value of fx equals 0. Fx equals 0, and when fx equals 0, so you can get x squared minus 6x plus 9 equal 0. This is the equation that you will get. Okay, next step, you factorize it. X squared minus 6x plus 9. Okay, the factors are x minus 3, x minus 3. So that means the x-intercept is 3. Now we draw the horizontal axis. Followed by vertical axis. Label the axis, the origin. Okay, then mark the y-intercept, so 9 is here, and the x-intercept 3 is here. Then you draw the curve of the parabola. Just like this. So here is our graph. So please try to draw the curve of the parabola as smooth as you can. Okay, let's try at C. Okay, for example, at C, given the function fx equals negative x squared plus 2x plus 15. Okay, the first step, determine the shape of the graph. We know that a equals negative 1, which is less than 0. Okay, less than. When you get something less, you will be unhappy. So the shape of your graph is a parabola with a maximum point. Okay, set symbol. Okay, set symbol. And then the second one, Then that C equal 15. So that means the y-intercept is 15. Okay, the third step, we determine the x-intercept. So the equation negative x squared plus 2x plus 15 equals 0. Okay, before we factorize negative x squared plus 2x plus 15 equals 0, first always make the value of a positive. So this means you have to multiply with negative 1. So you have to multiply all the terms in the equation with negative 1. Then you will get x squared minus 2x plus, minus 15 equal 0. Okay, then the factor x minus 5, x plus 3 equals 0. Therefore, the x-intercept are x equal 5 and x equal negative 3. Then we sketch the graph. Okay, label the horizontal axis and the vertical axis. Origin, okay, you mark the y-intercept 15. The y-intercept is 15. Next, the x-intercept negative 3. Negative 3, let's say around here, negative 3 and 5 is around here. And then you sketch the parabola with maximum point that pass through all of these 3 points. Okay, let's try the last example. For example 8, okay, given the function fx equal negative 2x squared plus 18, fx equals negative 2x squared plus 18. Okay, as you can see here, the value of b is 0. Okay, let's recall what you have learned before. If b equals 0 for a quadratic function, then the y-axis is the axis of symmetry of the graph. Y-axis is the axis of symmetry of the graph. So you must consider this characteristic later on. Okay, first, as usual, you determine the shape of the graph. So a equal negative 2, which is less than 0. Okay, less than 0. Okay, you get something less, you will be set. So you get a parabola with the maximum point. And then the second one, c equal 18. So that means y-intercept is 18. Then the third one, you determine the x-intercept. Okay, at x-intercept fx equals 0, you will get this equation. Always make a positive. Take out the common factor. Then you factorize x squared minus 9. Therefore, the x-intercept are -3 and 3. Then you sketch the graph. Label the axis. The origin. Mark the y-intercept. Then the x-intercept. Okay, then draw the curve of the parabola. Here we go, this is our graph. Okay, let's see this one. If b equals 0 for a quadratic function, then y-axis is the axis of symmetry of the graph. So this means the y-axis is the axis of symmetry for this graph. Okay, now we discuss example 9. Okay, example 9 is case 2, where the graph of a quadratic function does not intersect the x-axis. How do we know that quadratic function does not intersect the x-axis? Okay, we take a look at example A. Okay, this is example A, given the function fx equal x squared plus 1. Okay, let's follow these 3 steps. Okay, the first one, the shape of the graph. A equal 1 greater than 0. You will get a parabola with minimum point. Okay, then B, second one, the y-intercept, C equals 1. So that means y-intercept is 1. Okay, remember the value of B. The value of B here is 0. The value of B is 0. Okay, B is 0. So that means the y-axis is the axis of symmetry. Okay, the y-axis is the axis of symmetry. So we put it here first. Okay, so that means at y-intercept equal 1, therefore the minimum point okay, the minimum point is 0, 1. 0, 1. Okay, then you look at the third one. We know that this equation x squared plus 1 equals 0 does not have x-intercept. Okay, how do you know it doesn't have X intercept? Okay, let's try. We try to factorize it. So x squared plus 1 equal 0. Okay, use factorization. Let's say here is x, here is x, so you get x squared. So this is 1, this is 1. You will get positive 1. Okay, cross multiplication. This one x, this one is x. So if you add these two products, you will get 2x. Okay, let's say we change this with negative, we get positive 1, but here also still negative 2x. Okay, so that means this quadratic equation does not have X intercept. So don't bother to find the X intercept. Okay, you erase this one first. Okay. So the third step, we cannot find the X intercept. So we need to mark one point that passes through the graph. So you can mark any point, okay? Any point with any coordinate. For example, let's say I choose, we follow the example in your textbook, we choose x equal to, okay, then fx, you will get 2x squared plus 1 equal 5. Okay, now sketch the graph. We sketch the graph first. Okay, label the axis. Okay, the minimum point is 0, 1. So 0, 1 is here. Let's say 1 is here. Okay, then you draw the parabola, smile shape. The y-axis, sorry, the vertical axis is the axis of symmetry. So this is the axis of symmetry. So to complete the graph, so you need to mark one point. So just now we choose x equal to. So let's say 2 is here, so I mark 2 here. When x equal to, you will get y equal 5. Y equal 5. So this is our graph. Okay, now let's discuss the final example. Example 9b. Okay, for 9b, you are given the function fx equal negative x squared minus 3. Okay, a equals negative 1 less than 0. So you will get a parabola with maximum point. Alright. Then you know that b equals 0. Okay, b equals 0. Therefore, the x-axis is the axis of symmetry. Okay, x-axis is the axis of symmetry, so your graph should be like this later on. Alright, and if you can see here, the parabola cuts the y-axis here at the maximum point. Okay, at the maximum point. So if you determine the y-intercept, we can determine the maximum point. Okay, you know that c equal -3 from the equation, so this means the y-intercept is -3. So here is -3, so that means the maximum point is 0 and -3. Alright, and then we mark one point that passes through the graph, so we choose x as 1, x equal 1 as in your textbook. So when x equal 1, fx equal -4. Okay, then don't forget to mark 1, -4 on your graph. Okay, now let's sketch the graph. Label the axis. So 3 is here, -3 is here. Okay, then you sketch the parabola. Alright, then you mark point -1, -4. -4 is here. So 1 is here. One is here. So here is point 1, -4. So that is the end of our lesson. So that means we have finally complete chapter 1. So before we end this lesson, so you can try self practice 1.1G. Okay, make sure you do it. If you're able to do it, so that means you have achieved our learning standard today. Sketch graph of quadratic function. Okay, remember these few tips before you sketch the graph. That's all for today. Thank you for listening. See you again.